All right, so here we are continuing again on the 2021 AMC 10B problem 6. It was also the 12B problem 4. Miss Blackwell gives an exam to two classes. The mean scores, which is just average, of the students in the morning class is 84. Don't read on, make sense of what you're reading. So my preferred formula for averages is the sum of subscript n divided by n equals the average subscript n. Now you don't always write this. Sometimes you'll put a number, like in this case here. We're going to do the sum of the morning classes, sum m, divided by m being the number of students in the morning class. This is going to equal 84. And immediately multiplied to get that the sum of the m students is 84m. That's typically what you'll do with this every time, is immediately multiply by this. And the afternoon class's mean score is 70. So again, this time we're not going to actually write the a underneath because we anticipate multiplying by it. And just to save time, right? The ratio of the number of students in the morning class to the number of students in the afternoon class, so m over a equals 3/4. I'm just going to multiply by a. So m is 3/4 of a. We want to know the mean scores of all the students. Well, think about how would the mean be calculated? It would be the sum of the morning class plus the sum of the afternoon class divided by the number of students in the morning and the afternoon class. That's the average. We just need to find it. And the problem is we've got two variables and they're written in terms of a sum. So what do? We know that the 84m is here, but we see that m is 3/4 of a. Well, we're pretty good then. All we got to do is replace this m with 3/4 of a. You should recognize 84 is 21 times 4. And then 3 times 21 is 63. So if I replace the m with 3/4 of a, again, you're putting the 4 into the 84 to get 21 times 3, 63a. And then you're going to put that in place of the sum of m now, because this was the sum of m. So you'll have 63a plus sum of a, which we know is 70a, over it's going to be 3/4 of a plus a. You should get 7/4 a. Well, look at that. The a's all cancel. And now we're going to have, actually, I'm just going to multiply. It's basically the sum of this times, or divided by 7/4 is going to equal 63 plus 70 times 4/7. I didn't actually want to add, even though it's not bad. I don't know. I just saw the 7 goes into here really easily and into here 10 times. Most of you probably know that 133 divided by 7 is 19, but if you don't, sometimes it's easier to cancel when you haven't added it up yet. So 19 times 4, answer is going to be 76. Let's get the next problem. Well, it's that time for problem number 7 from the 2021 AMC 10B. In a plane, 4 circles with radii 1, 3, 5, and 7 are all tangent to line L at the same point A. I hope you caught that when you were doing the test. So we're going to have some random line L, but they may be on either side of L. Region S consists of all the points that lie inside exactly one of the 4 circles. What is the maximum, so we want, possible area of region S? So there's different possible areas. It seemed likely to me that I'm probably going to want the circle with radius 7 to be by itself, because you get more area out of it that way. If I had put a circle inside, I would have to lose that area. You'll see later there's actually a way to do it with that happening as well. The other side's going to have, I'm going to put the 5 going this way, right? And so already you're at what? 49 pi plus 25 pi. And that's going to be 74 pi, but we've got to put the other 2 circles somewhere, right? And so they don't have 74 pi here. They do have 84. I'll tell you what that's all about in a second. You're going to have to put the two circles either inside of this one or this one, but whichever side you put them on, you should put them together. That way this one's not taking up space. If you did that, if you separated and put like one up here and one down here of radius 1 and radius 3, you would have got the trap answer C, and that's going to be incorrect. Instead, if you fold this down, you don't actually lose any area for region S. So it's better not to put that one up there, or you can put them both up or both down. It doesn't really matter. In either case, you're going to have to subtract an area of 9 pi. So again, I can flip both of these two circles into the radius 7 circle if I want. I'm still going to have to subtract 7 or 9 pi. And the way that works is why? If I want the area inside of this circle, but not this circle, because if it was in this circle, it's inside of at least 2 circles. And so we can't have it there. So it's obviously going to be, right, if this is the middle, big pi r squared minus pi little r squared. Almost like concentric circle donuts, but not quite. So you'll subtract 9 pi from this. You will get 74 minus 9 is d, 65 pi. Where does the 84 pi come from? It comes from if you didn't catch that it has to be at the same point A, because then you would separate it out and you would have ended adding to this whole thing 49 plus 25 plus 9 plus 1. And that's going to give you 84. In other words, if you were allowed to have the circles be at different points on the line because you didn't understand this or you forgot it when you got to the end, I'm sure some people did that. Feel bad for that, but that's it. It's going to be D. Let's get to problem 8. Time for the 2021 AMC 10B problem number 8. Mr. Zhu places all the integers 1 to 225 into 225 15 squared, recognize it, into a 15 by 15 grid, makes sense. He places 1 in the middle square right here, 8th row and 8th column. There's probably a way to do it using the rows and columns in some formula, but yeah. And places other numbers one by one clockwise as shown in part in the diagram below. Let's see what they mean. 1, 2, it's going clockwise, 3, 4, but you can't go up, so you have to go over. 5, 6, 7, 8, 9, 10, like this all the way around. Okay, what is the sum of the greatest number, and the least number that appear in the second row from the top? Okay, we're looking for patterns. Now, could you do this with some formulas like R, 3R minus 2, something like that? Sure, whatever, knock yourself out. I'm not going to do it so formulaic. We're on problem 8. We can probably brute force this with some pattern recognition. So what I look for is here, like 1, 9, 25. Those are perfect squares. I don't know, there are things that stand out. There's a lot of problems where you're doing stuff like this that involve perfect squares. I think the one where we did the 2020, like negative 2020 something point last year was something similar where you went around like this, around on a coordinate plane, and I think it involved perfect squares if I remember correctly, but I can't recall. Anyhow, I know I've seen it before. So 1, 9, 25. Now, if this was all we had, the second row from the top, which is what we're going to use to think about what we suspect is going to happen in the 15 by 15 grid. Because we don't want to draw the whole grid. Good gosh, that would be horrible. We don't really want to do that. So let's look at this row. The smallest number in the row is right here, and the largest number is right here, right next to it. And if we had went to the inside column right here, where we're only focusing on the 1 to 9, this part doesn't exist yet, then if that was all that was there, this would be the smallest one second from top, and this the largest one within those 9. So it's looking like these two probably would be these two on the next one. So now we want to make our strategy. How are we going to get these two for the 1 by the 15 by 15? Well, for one, if I'm at 25, this is a 5 by 5 square. So if I was to subtract 5 from it, I would not be here, by the way, because there's 5 there, and 25 minus 5 is 20. But 20 to 25 is not 5 numbers, it's 6, right? Again, the formula for all the numbers from A to B is B minus A plus 1. So if I do 25 minus 21 is 4, plus 1 is 5. There's 5 numbers and you can count them on the board. So we don't want to get this number. If we were doing the 25 square one, we would want to subtract a full 5 down to here to get this number. And how are we going to get that number there, though? It probably would be that if you were in the row of 9, the previous size square, right, the 3 squared size square, that you would just go backwards from 9, 8, 7 to get this number, okay? So you would subtract 3, but then add 1, okay? So you could probably make a formula with that. All we're going to do is if you want to verify this is true, we're going to check this row here and verify what we think this number would be. First off, we would do 25. We don't actually want this 20 anymore. We would do 25 minus 5 plus 1, which is minus 4, to get ourselves the 21, which would be the smallest number in this row, right? In this row. Imagine this was the end of the problem after the next iteration. It's not. But we're trying to confirm our suspicion, right? We make a plan, we make a strategy, then we confirm and nail down that strategy. And then once that's done, it's just a matter of extrapolating it to the 15 by 15. So what we think is going to happen is I'm going to go 26, 27, 28, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 49. Notice I stopped writing the tens digit. Why? We don't care. And you don't have time to do that. Every digit saved on the test is time saved. This is exactly how I checked it on mine without writing the tens digit all the way around. Sometimes I did it a change in numbers. So if I did 49, this is the 7 squared, right? And I did 49 minus 7, where would I end up? 42, the largest number in this row. We've got it down. All we're going to do is take 225, which is 15 squared. We're going to subtract 15 to get 210. Then 210 will be the largest number in the row, the 14th row, if you will, the one row below the top. Okay? That's this number on the second from top row on a 15 by 15 grid. How do we get this number? Well, this was 7 squared. The block here was 5 squared. So we doing a 15 squared, we're going to go back 1 to 13 squared. Again, to understand, you've got 1 squared here, 3 squared here, 5 squared here, 7 squared here, right? You're only counting the odd squares. The even squares are down here, I think. Not slamming one of them, actually. Oh, yeah, it is. 36. That's 36. So the even squares are going down here, but we're not concerned with those. Okay? I did just notice it, but... okay, so then we want odd squares. If we just did 15 squared to get to our corner, right, then the corner in from that will be 13 squared, which is 169. So then from 169, you actually would just come over not the full, like I'm not going a full 5, I'm actually only going over 4, right? It's basically 25 minus 5, which would have put me here, but I need to go back up 1. So I add 1. You can also just do, instead of subtracting the square root of this, subtract 1 more, or 1 less, I don't know how to say it. You're subtracting 4, 25 minus 4. So for the 13 squared, it's 169, but instead of subtracting 13, subtract 12. So when you subtract 12, you will get 157. This is the smallest number in that row. This is the largest, 367, 367 is A. If you didn't make sense of this, try to watch it again. I tried to make sure I explained all the subtle details and nuance and all of that. But it's, again, you find the corner numbers, subtract a full square root to get here, and then go to the inner square, which is going to be 1 odd number less. And instead of subtracting a full square root, you subtract 1 less than that, basically. Yeah, that's about it. On to problem 9. Let's keep going. Here we are on the 2021 AMC 10B problem 9. It was also the 12B problem 5. Transformations in the plane, here we come. The point PAB in the XY plane is first rotated counterclockwise by 90 degrees around the point 15 and then reflected about the line y equals negative x. We don't quite know maybe what to do with that. You probably could. If you memorized your transformations, you're good, but this doesn't take that long to just figure it out. Let's see what we're talking about. The image of P after these two transformations is negative 6, 3. What is B minus A? Okay, so what we're going to do, I'm going to do anyway, is this. If you fold over negative 6, 3, okay, and you're here, and you just, I'm going to go in reverse. You just finished folding over the line y equals negative x. That's a really easy transformation to do. In fact, it's one of the only two that I actually remember, that one and y equals x. I mean, I commit to memory. You might want to memorize the 90 degrees counterclockwise one too. But to flip something or reflect it over this line is simply to switch and negate. Why? Because literally y is really negative x. And since x is negative 6, the new point y will be positive 6, the negative version of x. And since x would be negative y if I moved it over, the 3 is going to become negative 3. That's worth remembering if you didn't want to graph it, although this takes maybe 30 seconds more time by drawing a quick sketch to be sure of your answer. The next thing is it's going to rotate. Oh, this is why you can't use the counterclockwise rotation rule about 1/5. Maybe you can. There's probably some fancy schmancy, super smart way that you can do it if you're huge-brained. But for people like me and perhaps you, it's better to just think, okay, here's 1/5. If I'm going to rotate 90 degrees about that point, then counterclockwise would be this way. It's going to go up here, and this needs to be 90 degrees. Well, how does that work? They're perpendicular lines. We can do negative reciprocal slopes. So if I look at the slope from here to here, I'm going down 1, that's negative 1, and negative 3 to 1, you're increasing by 4. So your slope is down 1 over 4, which means the other negative reciprocal slope needs to be the negative reciprocal, 4. So if you're at this point, you're going to go up 4 and 1 to the right. You're going to be 1 to the right at 2, up 4 at 9. What is B minus A? B was the y, A was the x, 9 minus 2 is 7. We got D. Didn't take that long. You don't have to know any complicated formulas to do it. You can just figure it out. Incidentally, one more thing to point out is if you reflect like a point over the line y equals x, literally, y equals x. This would become, for instance, 9, 2 if you reflected it over y equal, because y is x and x is y. That's how that works. That's why I memorized those ones, because they're literally so simple to recall. But rotations and stuff, I don't know, you can usually figure it out with a little bit of ingenuity. Let's get to problem 10 for AMC 10B and problem 6 for the 12B. All right, so 2021 AMC 10B problem 10. It was also the 12B problem 6. Inverted cone, second time we've seen that in recent history. An inverted cone with base radius 12 and height 18. Incidentally, my solution to the inverted cone problem from A does have a better solution that I was able to work out later. I will refilm that to update it with a new video sometime next week or this weekend or in the future, sometime after this point in time. And explain how that works and why that other method works that you guys discussed in the comments as well. And I suspected something like that was up, and I knew I went the long way. It is what it is. Okay, so inverted cone with base radius 12 and height 18 is full of water. Since it's full, let's just find its volume, I bet, right now, because the water is going to be poured into a cylinder. So the volume of the cone is 1/3 pi r squared h. That would be 12 squared h 18. It's full, so we don't have to worry about anything less than the full amount of the cone. It's poured into a tall cylinder whose horizontal base, again, the volume of a cone is 1/3 pi r squared h. The volume of a cylinder is pi r squared h. Basically, the area of a circle times the height, that makes the cylinder. I would say it's like stacking CDs, but you guys don't know what that is. Tall cylinder whose horizontal base has a radius of 24 centimeters. That's a radius, not a diameter. So this one here is going to be pi times 24 squared. What is the height in centimeters of the water? Notice we don't need to know the height of the cylinder. Doesn't matter. because the water's only going to go to a certain height when the volume from this fills it up. So we're just going to set this equal to 1/3 pi times 12 squared times 18. And I know, you probably know the perfect squares of all. You can just calculate it. Don't bother. Come on, think. Look for chances to save time. Pi, pi. The 1/3 with the 18 gives 6. 12 squared, put it under here, and you can pull this squared to the outside. So it becomes 2 squared. Then you're going to get 4h equals 6. Divide by 4h equals 1.5. That's it. That's all you had to do. Pretty straightforward and standard boilerplate kind of problem. You did need to know the cone volume formula and the volume of a cylinder. If you didn't have these in your small notebook, you need to add it. If you don't have a small notebook, watch the how to prepare for the AMC 10 playlist. Yeah, it's in there. Check it out.